Hello everyone, welcome back to our Accounting 312. In this video, I want to talk about chapter 10 and then mainly just the regression analysis. So it's not, I don't think it's directly related with our textbook. So I would say use your high school, the regression analysis or your statistics class material and then check all the handout and the multiple choice that is related with the CPA exam. Okay, so let's get started. I don't want to say too much about this chapter because we are not a statistics class. But why we talk about this and why we have to do our second project, because regression is very important. Um, it's important for your work. It's also important for your daily life. Okay, so basic assumption and example of the cost function. So we still focus on the cost. We want to find out, hey, what activity causes our total cost, variable cost, fixed cost, total cost. I believe you already know this. We focus on linear cost function. We don't do these fancy things. We just think about it's linear. How the cost change with the change in the level of activity. So the y is called the dependent variable. This is the dependent variable. We want to predict the cost, or we want to predict anything. I always say, you want to predict, hey, how many total points you will get in the class, right? So this is the thing you want to predict. And x, we call it an intercept. So in the cost content, then it will be our fixed cost. And then we have our variable cost. This x is our independent variable. Y is dependent variable. Why? Because y depends on x. So y is the dependent variable, x is the independent variable. And this b is the slope, which we also call it a coefficient. And then x is just the cost activity. Next thing I want to mention that the the correlation doesn't mean causation. Correlation doesn't mean causation. So something is correlated, is related with another thing, doesn't mean that thing caused the other thing. So I got this example, found out that, hey, people in like Europe, they eat a lot of chocolate, and then they also have a higher chance to get Nobel Prize. Like other country, like my country, home country, we were so poor, we didn't get chocolate, and then we also didn't have a lot of Nobel Prize winner. But does that mean eating chocolate cause the higher chance to get the Nobel Prize? Doesn't mean that, right? It doesn't mean chocolate, you eat more, you will be smart, you will get Nobel Prize. I eat chocolate every day and I'm still not smart. So correlation doesn't mean causation. So just to let you know. Next one is the cost function. So we think about, as I say, there must be the economically plausible relationship, right? It makes a sense, how to say that, I turn on the light. Okay, so I turn on the light. So the longer time the light is on, the higher cost the utility bill will be. So you have to make sense, right? So that's the main thing. That's the main thing. Next one, regression analysis. Finally, make sure you know what's dependent and what's independent. We talk about that. So simple regression is just one. So y is only related with one x. But multiple regression, this is your second group project. So we have different variables. So you have 2 or 3 independent variables there. We use least square technique. You don't really need to know specific, but get some general idea. And I really think it's a fancy name you can show off. Hey, we use least squares technique, right? So what should we do is that the video shows you do a survey, you got all these dots, and then you can draw a line, and then you find out, hey, this line has the least squares residual, right? So this line can represent most of the dots. So let's say I draw a line here. I just make an assumption. Hey, I draw a line here. Then that doesn't represent all of the dots. then the residual from the dot to the new line will be larger than to this line. So this line has the least squared residual. That's the technique we are using, least squares technique. Residual term, so you predicted, let's say you predicted should be here, but the actual is here for dot 12. So this distance is the residual, right? This distance is the residual. Goodness of fit, I don't know you have heard yes or no, but basically it calls R square. R square with a larger is better. And then for the relationship, you know, for this one, it goes up, so that means there is a positive relationship. If it goes down, then that's negative relationship. Goodness of fit, I'm not going to say too much. It's textbook 400. Larger is better, so that means more portion of the variance in y can be explained by x. R, just R instead of R squared is called coefficient of the correlation. So R, it can be -1 to +1. So R, okay, I'll just put it here. It can be -1 to +1. Okay. Okay, but R square, since it's a square, so it can only be from 0 to 1. Okay, it can be only from 0 to 1. R is the coefficient of correlation, so whether they are positively correlated or negatively correlated. Next one. How do we interpret, right? How do we interpret? So we have this constant, we call it intercept, and then this is, we call it coefficient. We call it coefficient. So the constant means if there is nothing, right? There is no x, we don't even have anything. If there is nothing, our total predicted cost will still be $300.98. So it's a fixed cost. Right? So if, let's say, hey, you have a hotel, no matter people come yes or no, you have the insurance, right? You have the insurance, so that will be the fixed cost. But we also have the variable cost. So if you have more customers, they turn on the light, then you have to pay more bills. So the bill, utility, the electricity bill is the variable cost. So one more customer, I would just say, hey, one more customer turning the light will have your predicted utility bill increase by $10.31. So this is the average. This is not exactly, it doesn't mean, hey, I'm the customer, I go to your hotel, your bill exactly next month will increase by 10.31. Doesn't mean that it's on average, you know, you have 10 years, you know, on average, your predicted utility bill will increase by 10.31 cents. If you have one more extra customer coming. So the textbook also said the average amount will be increased by 10.31 for extra 1 machine hour. This is how do you interpret our coefficient. This is how do we interpret our coefficient. And then also we said, how do we make a prediction, right? So if we use 90 hours, so instead of using the X, we already know it's 90 hours. So we just replace the X with the specific 90 hours. So if we do that, you should get your predicted will be $1,228.88. So what we need to do when you do prediction is you replace that variable with the specific number. Okay, next one, we said, hey, which regression model you should choose. If I ask you in the exam, I'll give you these two tables, let's say 2 pictures. I said, hey, which one you should choose? Different ways to measure. First, we want to say the economic plausibility, you know, one is the machine hour, one is direct material labor hour. So most likely machine hour makes more sense. Goodness of fit, we compare the R square. This picture doesn't show us, but some pictures will show us. And then also significance of the independent variable. We will talk about this in the regression group project. But what we want to say from here is we want to say that the the slope flatter means less impact. Flatter means less impact. We want the slope to be stronger impact. No, but you basically you compare R square. If I test you in the exam, I will show you specific R square significance of the coefficient. So I can use some example to show you how can I ask you in the exam if I test you. Significant of the independent variable. So this is from your textbook. I do not expect you to know much, but you just need to know there is something called a p-value. There is something called p-value, and we want our p-value to be smaller. So there is something called a p-value. We want the p-value to be smaller. I will show you example in the practice or in the group project. Okay, next one, check residue. We want the residue to, random, there is no pattern. You don't see this pattern, like this pattern, they become larger and larger. You can kind of see the pattern will become like this. How do you see this in English? Like a microphone or something. It's just becoming larger and larger. This is not a good one. This pattern, you can see it go upside, up, down, up, down, up, down. So if you see a residual, that's not a good, if you see a pattern, that's not a good residual. Okay, so something talking about whether you think the cost driver makes sense, yes or no, we compare R square. So let's say, hey, one model R square is 52%, the other R square is 17%. You want to go with the R square of this one. Significance of the significance of the p-value, we said our cutoff is 5%. Our cutoff is 5%. If it's smaller than 5%, it's significant. If it's larger than 5%, it's not significant. So from those R square and the p-value, you should be able to get this Mercian error as our better model, predicted better model. So I'm not going to say too much, as I always say. You do your group project too, you will get a good understanding of chapter 10. And then since we are already here, sorry, give me 2 more minutes. Since we are already here, I want to show you what you need to know for chapter 10. For chapter 10. Come on. Learning objectives. So you have these things, you just need to know these, I think 3-4 parts, you just need to know this. That's all. Okay. So some terminology, coefficient of correlation, you need to know it from -1 to +1. But R square, it has to be 0 to 1. Slope of coefficient, that's what's the intercept, what's the dependent, what's the independent. And then make sure you know your group project Excel. It was group project 1, but I'll change it to group project 2. Pick the better regression model, get the larger R square, check the p-value, and then interpret the finding, make prediction. You will practice these two in the group project. Okay, so that's all you need to know about chapter 10. If you have any question, you know what you should do, right? Email me, always email me. I'm always here. Thank you.